Okay, so this Collins radio, made a couple plates, tested all the tubes, replaced a few tubes, rigged up a connection to this coax connector on the back, had to make another plate. Somebody, whoever had this before, didn't really take care of it and left a lot of stuff off of it. And we have this hooked to this variac right here. And then we're going to test it. So what's kind of the basic procedure that we're going to do to...
Well, I'm not having an amp meter or voltmeter, but let's...
Here, let me plug it in.
Okay.
Hold on. Ready?
Yep. So which way's on?
That way.
Okay. Okay, light's starting to light.
Heard something.
Tubes are lighting up.
Yeah.
Okay. Low voltage meter is starting to rise. Just let it sit there for a while.
And what is that meter?
That's the low voltage power supply.
Oh, so 110 volts.
No, the DC.
Oh, DC?
Probably like 300 or something.
Okay, there's 3 scales on it. Yeah.
Is there one that goes 0 to 300?
250, 500, and 1,000 at the
Yeah,
max.
I don't know which one's what. I have to look in the manual.
High voltage, low voltage. And we have a matching receiver which is on its way and should be here within a week. Probably by mid to end of next week. Something like that.
Unbelievable. From the beginning to the end.
This is Aaron Murakami with A&P Electronic Media at emediapress.com and the Energy Science and Technology Conference, energyscienceconference.com. And Eric Dollard and I and a few other people have put together this audio rack here. We're going through the testing process right now, and this is going to be, hopefully we're going to get as much done as possible with the hopes of being able to do some demonstrations at the conference. And then this is the RF rack with the Collins transmitter that's getting refurbished and put together. And this will be on that rack. And then this is a amplifier that uses these two 810 tubes. And we're just firing it up for the first time, and Eric is going through all the tests. He's looked at all the wiring underneath, which we showed that in the past. Quite an extensive network of wires underneath there. And what we're going to do is methodically go through each part of this unit and test it, and you'll be able to see it light up. And so you want to kind of go through what the procedure here is?
Yeah, so first there's the main power. And that activates what's called the bias supply. And you always want to make sure that you got hold-off bias on the tubes before you apply any power to them. So, and it's interlocked so that if the bias potential disappears, then the relay shuts this circuit down and doesn't allow the high voltage to be turned on. So then the next step is to light the filaments.
That's this meter right here.
So their maximum voltage allowed is, this is actually half scale because that's the only meter we have, but it's really 10 volts. But in this case it would show it as 5, so we're running a little high now because we have to change taps on the transformer. And then there's a fine adjustment, and that the resistor doesn't really match what's needed in the circuit, but that's kind of the problem when you're dealing with this eBay stuff. You don't get exactly what you want, so we have to fine-tune that.
So what's the next steps?
So then, after all this is on, then this switch turns on the high voltage rectifier in the bottom part of the rack there, and applies the 2,400 volts DC to the plates of the vacuum tubes.
That's this one with the red
There's a little relay
switch
in
there.
A little relay here that takes its command from the, it's kind of buried down in there, takes its signal from the vacuum tube unit, and then energizes the rectifier transformer, and then you get the high voltage DC.
There's the relay back here behind underneath this terminal strip here.
Yeah.
2,400 volt
Yeah.
potential transformer.
Well, nominally, it probably end up being a little higher to start with before you load it down.
And we just got this Tesla capacitor mounted. And then this unit right here
And that goes in
goes right
next.
on top. And it'll fill up this space right here.
So the scope works, the frequency generator works. So then the vacuum tube unit will go back in, that works.
And then we got the light box here.
Then we have to find something with a strong enough signal
And that'll go right here.
to go in to get the to get those vacuum tubes going. So that's still kind of a variable yet. Because there's another unit that needs to be built, the control grid unit, which is another full month project. So I want to kind of bypass that if we can and just do much initial testing before we get to have to start on that project.
You mean this one?
Yeah.
The amplifier?
Yeah, it's a big project. And then the other end is the is we're starting on the Tesla transformer. So I guess we can go look at the drawings.
Okay. Okay, so Eric's going to go through some of the details on the Tesla transformer that's going to be used to do the flame speaker, for example. So there'll be two of these?
Yeah.
Okay. And what's all the components here?
So there's two coils. They're all hooked in series, and this is the input, and this is the output. So this one's called the current coil, and this one's called the potential coil. And these are the coils in their actual.
Drawn to scale?
Yeah, they're full size. So this is kind of off here, but that's kind of how, one way or another it would look.
So it's about 4 inches in diameter by about 7¼ inches long. That unit right here.
This one's 5¾ inches long and
6
6 inches in diameter.
That'll be this one. And they're attached to a stand. That's the platform.
So this one's wound with 18 gauge wire, and this one's wound with 8 gauge wire.
So do the two inputs face each other?
Yeah. Well, no, it's adjustable. You can turn them around and make it so they're beam, like the
Okay.
MWO,
Yeah.
or you can turn them outwards to make sparks.
Oh, either. Okay.
So when you want to make sparks, you turn them outwards. And then
Okay.
you have to have a dummy capacitor on this side to compensate for the spark capacity on the other side. It's like a disc on a lead screw. So that's another thing that needs to be made. And then there's a sheet of copper underneath here that establishes zero potential plane.
And so this one will have 18 gauge wire?
Yeah, insulated with Teflon. Voltage is very high. That's why it's called the potential coil.
So it's about 30 turns?
Yeah, this is where all the current hangs out, and this is where all the potential hangs out. Because there's a standing wave distribution on these that's close to a quarter wavelength.
Okay, this is number 8. Uninsulated, just bare wire?
No, it's got to be insulated because copper's got to stay shiny. It's got to be silver plated or it's got to be enameled,
This says uninsulated bear?
uninsulated, plated with silver.
Oh, okay.
I mean, you could do that, but I think the enamel would do it just as good. So this coil will be operated in a manner that no one else has ever really done before,
Okay.
because they haven't been paying attention to how Tesla's work progress, and everybody just keeps repeating the same old mistakes over and over again.
So what's the unique attributes about this
There's,
particular setup?
It will work without a primary secondary. That doesn't necessarily mean, though, that's the way we'll operate it finally, but when it connects to the Collins, there'll be no primary or secondary. The Collins will do all that work. The only reason for the primary secondary in Tesla's stuff is because he was using disruptive discharge. Well, we're using vacuum tubes.
And so this is not considered primary, secondary?
No,
So this is going straight to extra coil,
this is an
What
extra
you've been-
coil. Yeah.
the configuration of
Whole
both those
thing is
coils
the extra
together.
coil. Yeah,
Okay.
the two of them together are the extra coil.
Okay.
So it'll be series fed from a 1/2 to 1 ohm impedance out step down transformer, and then that will connect to the coaxial output of the 100-watt HF transmitter that the Collins. Basically, the Collins is a miniature version of what the rack's going to be filled with. So we'll start off with 100 watts. So because this is the star of the show, we have to really concentrate on getting this thing together and then work backwards. Because as you remember, the audio part was for other purposes, which led to this. So,
Right.
so the objective this round is the audio rack should be complete, at least enough where it can light the light bulbs.